Physics, Chapter 1 review. Question 1. The slope of a velocity time graph is the blank of an object. So if we look at a v versus t graph, okay, the slope of this line gives us what? So remember that slope is rise over run. If we look at rise, that's our y values. Run is our x values. So have a look at your graph and see what's the value for y. So in this case, it's v. And my x values are t, time. So if you look through your formulas, what does v over t give me? V over t is the equivalent to a. Okay, acceleration is change in velocity over time. So this would give you d, acceleration. Number 2, we skipped. Number 3, question 3, if you graphed distance versus time, so if we look at d versus t, what would the slope of 0? Well, first of all, what is the slope of a d versus t? Same method we used last time, rise over run gives me d over t. D over t, distance or displacement over time, gives me speed or velocity. So if the slope is 0, that tells me the object's not moving. It has a speed of 0, so the object is at rest. Number 3 is C. Number 4, we're looking at D versus T graphs, and I'm looking for an object with increasing velocity. So this means non-uniform motion. Remember that D versus T for non-uniform produces a curve. Because it's increasing, the curve is going to slope up like this. If the object was slowing down, it would still be non-uniform, but the curve would look like that if it was slowing. So number 4 is C. Number 5, if an object is traveling 10 meters per second east, so let's look at our compass here. Remember that north and east are considered positive. South and west are considered negative. So this object is traveling in the positive direction. Okay, they're traveling east, and they're speeding up. So is this object experiencing a positive acceleration? Acceleration is a vector. Yes, they're speeding up. Yes, they're going in positive direction. So this is true. Number 5 is true. Number 6. Same thing, except now we're traveling in a negative direction. So south and west are negative, north and east are positive. So even though this object speeds up, they're traveling in the negative direction. So this vector would be negative. Okay, acceleration is a vector, so that means it can be positive or negative. If an object was falling, that would be another example. Down is negative direction, so the acceleration would be negative. So direction matters because it is a vector. Number 7, a boat travels at a velocity of 8 meters per second. So here's a calculation problem. So start by recording all the information you're given. So I'm told that it has a velocity of 8 meters per second, north, so it's positive, and it's traveling for 14 seconds. So time is 14.0 seconds. What is the displacement of the boat? So we have to use our velocity formula, which is displacement over time. If I'm solving for displacement, so I'm trying to isolate d, that means I need to cancel out time. To cancel out a variable or to move it over to the other side, you always have to perform the opposite operation. So here, if I'm dividing by t, I need to multiply by t to cancel it out. That means I need to multiply by t over here as well. So when we do that, when I cancel out the t, I'm left with displacement equals velocity times time. So then we just sub in our numbers. 14 seconds. My velocity is 8 meters per second. When I multiply seconds times meters over seconds, this is going to cancel, leaves me with meters. 14 times 8 gives me 112 meters. For significant digits, we would want 3, so we leave our answer like this. So 1 mark, number 7 is 112 meters. Number 8, a bird is traveling at a speed of 10 meters per second. I'm not sure what stikes is, probably it strikes a window though, and comes to rest in a time of 0.03 seconds. So it's traveling pretty darn fast and comes to a very abrupt stop when it smashes into this window. So let's write down what we know. This is non-uniform motion, so we're probably dealing with acceleration. The initial speed that this bird is traveling at is 10 meters per second. Okay, the final speed, remember anytime you see the word stop or at rest or anything like this, means that it is at a speed or velocity of 0. So if we look at our acceleration formula, we can also write it like this, Vf minus Vi over delta t. My time is 0.0300 seconds. If I sub in my values, so Vf is just 0 minus 10 meters per second all over 0.0300 seconds. 0 minus 10 gives me negative 10 over 0.030. This gives me negative 333 meters per second squared. Okay, it's very important that it shows a negative because the object is slowing down. So give them a half mark if they just put 333. Give them a full mark if they put negative 333. Second last question. A person applies a 100 Newton force to a brick wall. The brick wall does not move. So that means the displacement of the brick wall is 0 meters. Total work done is 100 Newton meters. Remember, work is force times displacement. So we need to apply a force and the object has to move. If my displacement is 0, so if I subbed in 100 newtons, anything times 0 is 0. So my work done is 0 Newton meters, or I can write that as 0 joules. So this is false. Last question. Object traveling at 3 meters per second has a mass of 15 kilograms. What is the kinetic energy of the object? So I'm looking for EK. My formula for kinetic energy is 1/2 mv squared, which can also be written as mv squared over 2. My units that I want for speed are meters per second. My units for mass are kilograms, so I don't have to convert the mass. Sub it in, 15 kg times 3 meters per second. The 3 is squared, okay, all over 2. So when we simplify this, make sure you're only squaring the 3 meters per second. So it's 15 times 3 squared, and then divide that by 2. We get 67.5 joules. I only want 3 sig digs, or sorry, I only want 2 sig digs. So this should be 68 joules.